having parameter mu plus lambda. Okay, so here's some good problems for you to solidify these concepts. In the first hour that a bank opens, the customers who enter are of three kinds: those who only require teller service, those who only want to use the ATM, and those who only require special services, neither the tellers nor the ATM. Assume that the number of customers of the three kinds are independent of each other, and also that T is the number that only requires teller service, has Poisson 6. A is the number that only requires ATM, has Poisson 2, and S is the number that only requires special services, that's Poisson 1. So let's just think about what this is saying. So which of these types of customers comes in most often, T, A, or S? Now I can just imagine in class that everyone's going to raise their hand and say T. And then I'm going to say, why? Because it's Poisson 6. What is that? Why would you know that? Because 6 is the average number of customers that are coming in that are teller customers in an hour. Oh, and A is then second most because 2 is the average number of ATM customers that are coming in, and so on. So indeed, if I had 9 customers come in, I might expect 6 of them to be teller, 2 of them to be ATM, and 1 to be special services. Okay? So now, suppose that you observe the bank in the first hour that it opens. What's the chance that 12 customers enter the bank? Okay, shut off the video. I'm watching you. Try this problem. Okay, we're back, and we know how to do this problem. So it's asking for customers, and customers come in 3 varieties. There's teller, ATM, special services, and X is Poisson 9 because AT and S are independent Poisson and the parameters add, and I'm asked for the chance that I have 12 customers, so I'm going to whip out my Poisson formula. No problemo. Next question. What's the chance that customers do enter but none require special services? Okay, I'm just going to give you a hint real quick. You can interpret but as and. Okay, shut off the video. I'm watching you do this problem. Okay, we're back. This is asking for the probability that I have no special service customers and that teller plus ATM is greater than 0. So this is the probability that S is 0 times the probability that T plus A is greater than 0 by independence. And now I'm going to use my binomial formula e to the minus 1. 1 is the parameter for special services. I'm not writing the 1 to the 0 divided by 0 factorial, since that's just 1. Then times T plus A, 1 minus e to the minus 8. Since that is the probability that I have 0, that T plus A is 0, which is the complement of T plus A is greater than 0. One more part. Okay, find this conditional probability that T is 3 given that X is 10. Okay, shut off your video and give it a try. Okay, we're back. So let's see. Shaking off the cobwebs, conditional. Oh yeah, Bayes' rule, no problemo. So this is probability that T is 3 and X is 10. given that probability that x is 10. Now, x and t are not independent because x contains t, so I'll have to write this using the multiplication rule. So this is the probability that x is 10 given that t is 3 divided by the probability that x is 10. And this conditional here is just the same as the unconditional that a plus s is 7. So now I'm good to go. So this is e to the minus 6, 6 cubed over 3 factorial, e to the minus 3, 3 to the 7 over 7 factorial. No. Divided by e to the 9 minus 9, 9 to the 10 over 10 factorial using my Poisson formulas. Now, my algebraic heart just can't contain itself, and I can see that I can cancel these exponentials here, and that's a beautiful thing. And then my algebraic heart wants to do some write this complex fraction as a non-complex fraction. So this is 10 factorial over 3 factorial, 7 factorial, 6 cubed, 3 to the 7 over 9 to the 10. Now, the probabilists in me looks at that 10 factorial, 3 factorial, 7 factorial and says, I've seen that before. This is 10 choose 3. How curious. That's part of the binomial formula. How could I make this into a binomial formula? I even see the power of 3 and the power of 7 there. What if I write this as 10 choose 3, 6 over 9 to the third, 3 over 9 to the 7. Genius! That's genius. Here, this is the binomial. This is binomial 10p. P here is 6 over 9. What's 6 over 9? Oh, yeah. Remember, if we have 6 people in the bank, Poisson 6 in an hour, Poisson 6 tells me that on average, 6 of them will be teller service. So 6 over 9 is the average number. This is the average number of teller service customers out of 9. Right? So, in other words, the chance of having a teller service customer is 6 over 9. And that is a cool way to think about this conditional probability. So the probability that I have 3 teller service, given that I have 10 customers in the bank, is nothing but a binomial, is given by a binomial formula where so I have 10 trials to 10 customers, and the probability of a success is that a successful trial is that the customer is a teller need customer, and the chance of that is 6 over 9, given by the Poisson parameter. That is totally cool. I'm impressed. Okay, next topic.